I'm going to do the trigonometric way of doing number 10. And so I'm not going to draw this to scale at all using a ruler or a protractor. I'm just going to draw this by hand. And it says a plane is flying 200 miles an hour at 45 degrees. So what I'm going to do is I'm going to simply draw a vector that represents that plane. And so here's going to be 200 miles an hour, and that's roughly 45 degrees. Okay. And I'm also going to draw the wind vector. It's going kind of a 15 mile an hour wind blowing 30 degrees south of west. Well, here's west over here. So going to the south means this way. So I'm going to go like 30 degrees south of west, which would be something like that. Again, I'm not drawing it to scale. So this is a 15 here. And the whole point of the trigonometric way is this. If I could add the x direction of the plane and the x direction of the wind, I would get the x direction of the resultant. In other words, the resultant is where the plane's actually going to go. So what we're going to do is we're going to do these 5 steps here that you see. We're going to add all the x components. Then we're going to add the plane's and the wind's y components. We're going to redraw them, use the Pythagorean theorem, and do the inverse tan. So if you want, just go ahead and stop the tape, write those 5 rules down, and you'll sort of see where we're going. So what I'm going to do now is this. I'm going to show you how we can break these blue vectors for the plane and the wind down into components. So I've already broken them down into the horizontal component, which is written in red, but it also has a vertical component, which I'm going to draw in green. So that's the green component of the plane, and here's the green or the vertical component of the wind. Well, if you remember from math class, we call these different sides different things. For instance, the red side is the adjacent side for both of them here. Okay. And the green side was the opposite side. It happens to be the opposite side for both of them again. So this is opposite here. And I'm going to go ahead and make that a 15 degree angle. I forgot to put that in, not 15, but a 30 degree angle down here. Okay. And what we're going to do is now we're going to look at all just the x components since I wrote them in red. Let me go ahead and put them in red up here. And since we're looking to find the adjacent side, that red side is the adjacent side, I want you to sort of remember some of the trig functions that you learned. It was cosine was adjacent over hypotenuse. Sine was opposite over hypotenuse. And then tangent was opposite over adjacent. Remember SOHCAHTOA? And so since I'm looking for the adjacent side, and I know the hypotenuse for each one of those triangles, let's find out what is the vector in the x direction for the planes. I'm going to put a little p here, a little px for plane. And I'm going to solve for the adjacent side. Well, let's look at this first triangle. If I put my hand over this A right here, you'll see that the formula for A, the adjacent side, equals the cosine of the angle times the hypotenuse. Well, let's go ahead and just plug that in then. So that means the plane's x direction equals the cosine of 45 times the hypotenuse, which is 200. And that answer simply gives you 141. I'm also going to do the same thing for the wind. So I'm going to have the W in the x direction, or the wind in the x direction, and look at the same thing. I'm looking for the adjacent side, so I'm going to cover up the A. The formula, once again, is cosine times hypotenuse. So I'm going to put the cosine of 30 times the hypotenuse, which is 15 miles an hour. And that answer ends up giving me, I'm going to round up to 13, but it's a negative 13 because it's going to the left. The first one was a positive 141 because it's going to the right. Well, if I add these two x directions, I'm going to get the resultant's x direction. In other words, how far is the plane going to go, not how far, but how fast is the plane going to go in the x direction with the wind blowing against it? And so the resultant's x direction, when you add these two things up, 141 minus 13 gives you 128 miles per hour in the x direction. Well, now let's take a look at the y direction. That's step 2. Step 2 is right here. And in order to find the y direction, if you look at this side right here, you see how it's the opposite side for both the plane and the wind, and you know the hypotenuse is 200. So now I'm going to put the plane in the y direction. Once again, is the opposite side, and so that ends up equaling sine of theta times the hypotenuse. So I'm just going to put down the sine of 45 times 200, once again, gives you 141. Then we're going to do the same thing for the wind. Uh-oh, I just put, that was dumb. So I'm going to put W for wind in the y direction. Now we're going to do the sine of 30 degrees times 15 miles an hour. That ends up giving you 7.5, but it's negative because it's going backwards. So we're going to add the y's all together, and that ends up giving you a resultant in the y direction of 133.5. Well, I don't really care how much the plane's going in the x direction and the y direction separately. I want to know how fast is it going all together. So it's actually, let's do number 3 now. I'll draw this in blue. The plane is going in the x direction of positive 128. So I'm going to redraw this. I'm doing step 3 here. Okay. So I'm going to redraw 128. I drew it to the right because it's positive x. I'm going to draw a positive y direction here of 133.5. But the plane actually goes like this. This is blue dotted line. That's where the plane's actually going to go. So we have to figure out what is the length of that blue line to get the magnitude. And we have to find what's the angle. So let's do steps 4. I'm going to do step 4 in blue. It says use the Pythagorean theorem to find the resultant magnitude. Well, a squared plus b squared equals c squared. So c is the resultant here. So I'm going to say c is the square root of a squared, that's 128 squared, plus the 133.5 squared. And when you get that answer, that ends up being 185 miles an hour. And I think when we did it using the ruler in the last video, I think we got 187. So this is much more accurate. We were a couple miles per hour off using a ruler, and that's why you don't usually use rulers for this. Okay? So that gives me the resultant velocity. But you got to do the last step now. We have to now find out what is this angle. Well, let's think about what you know. You know the opposite side, and you know the adjacent side. So we have to use this triangle up here, the TOA. So we're going to find now, let me go down here. Give us a little bit of room. I now want to find the angle that it's going at. So the tangent equals opposite over adjacent. So that means just the angle is the inverse tan. So I'm going to take tan to the -1. The opposite side is 133.5. The adjacent side was 128. And when you end up doing that, you end up getting 46 degrees. Now I want you to pay real close attention here. I drew the red line first. This red line was drawn first. So that was going east. And then I drew the green line on top of that. So I went north of east. The first line you draw is the last direction you say. Let's say that again. The first line I drew was the east line. So it's going to be the last direction I say. So since the green line was north from east, this is 46 degrees north of east. So when you draw this angle, you start down here in the red, and then you go up towards the north. And that's how you do it trigonometrically. I'm going to do a third video that's going to be page 3 of the vector notes.